while Toyota, Samsung, and Western giants quietly test their scale down. Battery technologies. Huawei has just played a wild card that sent shockwaves through the entire auto industry. A solid-state battery potentially capable of delivering a jaw-dropping 1,968 mi or 3,000 kilometers range for electric vehicles. This is no longer a competition between individual models or brands. This is a survival race. If other automakers don't catch up with this technology within the next 2 to 3 years, they risk losing the market altogether. We're talking about batteries with twice of the energy density of today's 4,680 cells, a 4-minute charging capability, and a battery architecture that tackles the biggest flaw of solid-state tech: rapid degradation. And perhaps the most chilling part, Tesla is going a line on this front with a cold ambition, pushing past 1.3 million vehicles per year at its Shanghai Gigafactory. After all, Huawei is just one name among over 7,600 battery patents filed annually in China. And in the end, it's no longer about who leads on paper. It's about who can turn lab promises into mass production reality. The answer may well shape the entire future of transportation in the decade ahead, and you need to know about it now. Welcome to Tesla Car World. How does a 1,968-mile battery truly lead the pack? Is it for real, or are they just blowing smoke? Let's be real. Nobody saw this coming. From Huawei, we mean this is the phone company we all know, the one always in the headlines for clashing with Western governments. They're not a car maker, and they've never been a big name in batteries either, but out of nowhere, they drop a bombshell, a brand new solid-state battery with energy density, hitting 500 watts per kilogram. To put that into perspective, that's nearly double what you'd find in a current Tesla long-range model, and it's not just about cramming in more energy. Huawei claims they've tackled the biggest issue that's held solid-state batteries back for years: the rapid breakdown at the interface between lithium and the solid electrolyte. Basically, most solid-state batteries degrade fast, especially at the point where the magic happens. But Huawei says they've fixed that by doping sulfide electrolytes with nitrogen. Sounds super technical, but the short version is it works. If true, this could be the missing puzzle piece the whole industry has been looking for. Now, about that. 3,000 kilometers range, or around 1,968 mi. Yeah, sounds kind of wild, right? Like, why would I need to drive from Los Angeles to Chicago without stopping? But that's not the point. The real value here is flexibility. Automakers could use this tech to either build smaller, lighter, more efficient EVs, or just keep the same battery size and give drivers 1,000 to 1,500 meters of real-world range. Either way, that's bad news for gas engines, because suddenly EVs wouldn't just be cleaner. They'd be better in almost every way. Lighter, faster, longer range, cheaper to fuel. Game-changing stuff. Let's talk about charging for a second. One of the biggest gripes people still have with EVs is charging time. What if I forget to plug in overnight? What if I'm in a hurry? Well, that excuse is about to expire. Companies like Zeek, BYD, and Xpeng are already testing batteries that can charge in just 5 minutes, enough to give you around 300 meters of range. And no, this isn't just happening in China. Ultrast charging stations are being installed across Europe, the US, and even Australia. Before long, charging an EV will be like grabbing a cup of coffee. You pull over, take 5, and you're good for the next few hundred miles. Now, let's not get ahead of ourselves. This tech still costs a pretty penny, up to $1,200 per kilowatt hour. That's about 20 times more than your typical LFP battery found in affordable EVs today. So yeah, early models using this battery will be high-end. Think luxury cars, supercars, or cutting-edge electric SUVs. But remember how OLED TVs used to cost an arm and a leg? Now you can grab one at Walmart during Black Friday. Solid-state batteries will likely follow that same curve. Premium today, mainstream tomorrow. So, is Huawei leading the pack, or are they just making a lot of noise? Honestly, it's too early to say. They've filed patents and made bold claims, but there's no car in any dealership you can actually buy yet that uses this tech. Still, one thing's clear. Chinese tech giants aren't playing around. They've got the cash, the talent, and the motivation to shake up the EV world for real. Meanwhile, over in Japan, Toyota promised back in 2021 that they'd have a solid-state EV ready soon. Well, it's 2025 now, and guess what? Still no sign of one hitting the lot. At this rate, it's starting to feel like waiting for Half-Life 3. Everyone says it's coming, but no one knows when. So yeah, Huawei. Jumping into the battery game might seem random at first, but when you look closer, it might be the start of a major shift, not led by the traditional car makers, but by tech companies with prove. And when companies like that get serious, well, the rest of the world better pay attention. So, between solid and semi-OLED battery, why Huawei's 1,968-mile battery could leapfrog 24 meters tech in the fast-evolving world of electric vehicle technology. Two disruptive battery technologies have emerged from opposite sides of the globe. On one hand, we have 24M Technologies, a US-based startup that stunned the battery world with its Eternalite electrolyte, enabling rapid charging, outstanding cold weather endurance, and world-class safety features, all without resorting to solid state. On the other, we find a surprising new player in the EV battery game, Huawei, the Chinese tech titan better known for telecommunications than transportation. Yet Huawei's recent announcement, a solid-state battery with an energy density of 500 watt-hours per kilogram, enough to power a car for up to 1,968 may prove to be the more disruptive of the two. While both technologies represent remarkable engineering, Huawei's foray into solid-state power reveals deeper, potentially more transformative implications for the industry. It's not simply about high numbers. It's about redefining the physics and scalability of battery design in a way that could render today's EV limitations obsolete. Let's start with the raw numbers. 24M's Eternalite system combined with their novel Impervio separator reportedly achieves 660 watt-hours per kilogram, the highest energy density ever, confirmed in a non-solid state battery. This enables theoretical ranges of up to 1,000 miles, 1,600 kilometers, and fast charging, times as short as 4 minutes for 300 kilometers. Huawei's technology on paper falls slightly behind in energy density, 500 watts hour per kilogram. However, that's a misleading comparison if viewed in isolation. Huawei's battery is fully solid state, meaning the form factor allows for greater safety, packaging, efficiency, and system integration. Solid-state batteries eliminate the need for bulky cooling systems and complex thermal controls, which means more of the car's weight and volume can be devoted to usable energy. Thus, while the per-kilogram energy metric favors 24 million, the real-world system-level energy density, taking into account packaging, thermal management, and fire's safe young,
very likely tilts the balance toward Huawei. Moreover, Huawei's innovation isn't just a speculative claim. They've filed a critical patent that outlines how they've overcome the long-standing Achilles heel of solid-state batteries, the rapid degradation at the interface between lithium metal and the solid electrolyte. By doping sulfide-based electrolytes with nitrogen, they reportedly stabilize the material interface and dramatically reduce the electrochemical decay that has long prevented solid-state batteries from achieving commercial viability. In doing so, Huawei appears to have crossed a scientific threshold that countless battery researchers have been chasing for over a decade. 24 million batteries enable impressive range up to 1,000 miles. But the implications of Huawei's technology stretch even further. The 1,968-mile range potential completely reshapes what is physically possible in EV design. This is not merely a question of efficiency. With such a leap in usable energy per charge, automakers gain flexibility. They can build compact EVs with half the battery size, reducing weight cost and resource consumption. Or they can maintain current battery sizes and deliver ultra-ONG range vehicles that eliminate range anxiety for good. They can optimize battery placement and design architectures that were previously impractical due to heat weight or cooling constraints. No less important is the potential lifespan and degradation profile. While 24M's electrolyte dramatically improves lithium battery performance, especially in cold weather, it's still bound by the inherent constraints of liquid electrolytes, including issues like gradual capacity loss and dendrite formation over long charge cycles. In contrast, Huawei's solid-state approach minimizes dendrite risk, operates without flammable liquids, and can theoretically maintain capacity for thousands of cycles with far less degradation. 24 megabytes currently leads in charging speed metrics. The ability to deliver a 4-minute charge for 200 miles or 300 km without requiring ultra-high voltage infrastructure is a major practical benefit, especially in countries lacking dense EV charging grids. Their Eternalite technology also sidesteps the need for 1 megawatt chargers, allowing 24M equipped EVs to thrive even on standard 400 or 800 VT systems. Huawei has not yet released real-world data on charging speed, and it's possible that initial versions of their solid-state battery won't match 24M's blistering charge times. However, this doesn't mean Huawei lags behind. Solid-state chemistry naturally lends itself to higher charging potential, as thermal issues are minimized and voltage tolerances are higher. Once infrastructure and power electronics catch up, Huawei's batteries could charge at faster speeds without the need for elaborate liquid cooling systems. Moreover, the need for ultra-fast charging is arguably reduced by Huawei's energy reserve. If a car can drive 500 to 2,000 kilometers on a single charge, users may only need to recharge once every week or two, changing how we think about EV ownership entirely. Safety is a critical concern in battery design, and here, both companies deserve credit. 24M's Imperio separator offers state-of-the-art protection by suppressing dendrites and enabling early detection of internal shorts. Their battery platform maintains 80% capacity even at +40 degrees, see a milestone, unmatched by current lithium-ion solutions. This makes 24M's technology ideal for cold weather regions and contributes to the claim that their electrolyte might be the most robust non-solid-state platform ever built. Huawei's solid-state system, however, eliminates the core fire risks altogether. By using a non-flammable solid electrolyte, they bypass the possibility of thermal runaway, the primary cause of EV fires and recalls. While Impervio is a remarkable safety innovation for liquid batteries, solid-state remains inherently safer, offering a fundamentally fireproof architecture that regulators and automakers alike will increasingly demand. 24M's greatest strength is its scalability. Eternalite and Impervio can be licensed and integrated into existing lithium-based battery production lines with minimal retooling. This lowers the barrier to adoption and offers an immediate pathway to market. Huawei's approach, by contrast, is longer-term and more disruptive. Their battery is likely still in early prototype or lab-scale testing. Manufacturing solid-state batteries at scale remains a challenge, and cost per kilowatt-hour is currently estimated at 20 times that of LFP batteries. But as we've seen with Shreen's lithium-ion cells and other technologies, costs drop rapidly. once manufacturing matures. The big picture here is that Huawei is not simply building a better battery. They are building a new battery paradigm by investing heavily in material science, interface stability, and solid-state architecture. Huawei is setting the stage for the post-lithium era. 24M Battery is, by many metrics, the best liquid-based battery system the world has ever seen. It is fast cold resistant, efficient, and safe. An ideal solution for the immediate future. But Huawei's battery hints at something bigger, a step beyond the boundaries of what we thought possible. With nearly 2,000 mi of range, non-flammable chemistry, and the potential for new vehicle design philosophies, Huawei may not just be improving EV batteries. They may be redefining what a battery-powered vehicle is. How will these batteries impact Tesla affordability? Such a breakthrough aligns perfectly with mass-market vehicles. Take Tesla's rumored 25,000 Model 2 EV Gen 3. A solid-state battery like Huawei's would reduce cost, meet strict tax credit criteria, and unlock exceptional range, making it globally competitive even before subsidies. A3, 3,000 range, would make the Model 2 a disruptive force in regions with poor charging infrastructure, especially Southeast Asia, Africa, and Latin America. Even if initial deployment is limited to premium models, the long-term strategy is clear. Replace lithium-based cells in entry-level EVs to meet cost and policy targets. This gives both Tesla and emerging automakers a blueprint for scaling sustainable, locally compliant vehicles without relying on vulnerable lithium supply chains. Additionally, Huawei's battery could revolutionize stationary energy storage with zero risk of thermal explosion, ultra-long cycle life, and efficient performance in cold climates. These cells could power everything from remote data centers to decentralized renewable grids, especially in places like Tibet, Scandinavia, or Alaska, where lithium storage suffers. The ability to discharge down to 0 volts without damage enhances flexibility for off-grid use. From a manufacturing standpoint, Huawei's battery maintains partial compatibility with lithium-ion production lines. Retooling costs are estimated at only 10% over existing ion factories, making the transition economically viable. This is key for gigafactory owners reluctant to overhaul infrastructure. The core science behind the battery centers on solid electrolytes and advanced nano-ruptured electrodes. Unlike conventional graphite anodices, Huawei's model may use engineered ceramic or sulfide-based electrolytes, paired with high-capacity metallic lithium or silicon anodes. These offer high ionic conductivity, thermal stability, and better interface contact, all key to delivering both fast charging and longevity globally. This puts pressure on companies like Toyota, Samsung SDI, and Quantum Cape, who have been researching solid-state batteries for years without commercial rollout. Huawei's unexpected leap forces these players to accelerate. Even Tesla, though silent, is rumored to be working on parallel architectures and has already registered several relevant patents. Should we trust a tech company like Huawei to lead the EV battery revolution? Or should car makers stick to what they know, tech giants versus automakers? Who wins this race, please? Share your opinion in the comment section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla bot, don't forget to hit the like button and share this video. Also make sure to subscribe and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.